So, what did we learn last class?
Electromagnetic radiation.
Okay, what else? Planck's constant, which is? Right up there.
Right there.
Okay, and what does that number represent?
Speed of light.
No.
Oh, it don't?
Speed of light is energy, which is 3 times 10.
Someone tell me what Planck's constant means. Yes, Jay.
Planck's constant denotes how much energy a particle has at any given point.
Yeah, so
Good
basically,
job.
that if an atom needs to vibrate or transfer energy, it needs to have at least this amount. So that's the number that we use as a base to figure out any other energies that we need to figure out, okay? And we use this problem as an example. For example, if I asked you this, what is the frequency of an X-ray photon with an energy of 80 keV? So we already know that base constant number to figure out this formula, right? So if we didn't know that base number, there's no way we could calculate this. Kinda like if you know that 1 kilo equals 1,000 milligrams, whatever, if we didn't know that number, how would we do the rest of the calculations, correct? So it's kinda like that. So, some important things to understand. In the electromagnetic spectrum, wavelength is either very, very large or very, very small. And do you guys remember how it was written on the chart that I showed you?
Some of the radio waves.
In exponential form, right? It was either 10 to the power of negative something or 10 to the power of positive something. So they're either very, very large or very, very small. Same thing with frequencies. They're also either very big or very small, and they're also written as exponents. So for X-rays, do you think it has short or long wavelengths?
Short.
Short wavelengths, okay, and what does that say about its frequency? Very high,
Frequency,
and then
high energy.
energy is very high too. Alright. So X-rays, they have frequencies measured in million to trillion of hertz. Example would be 10 to the power of 19. Yes.
So if it's low wavelengths, it has low frequency, low energy?
So if the wavelength is long,
Uh-huh.
it has low frequency.
Yeah, I was just making sure, cause I know you had said wavelength and frequency
Are
is
inversely
inverse,
related.
so, okay.
And wavelength is either short or long. Don't say it's like a low or high.
I
Yeah.
gotta say it, that's the way I understand it, so if I say, cause if I say
Okay, well, if
that,
you understand though, that's
yeah,
fine,
so I have to, yeah, you know I'm wrong, but I understand it. Thank you.
And
Okay.
I
Yeah,
switch
you're
the
welcome.
slide.
Yes.
So yes, wavelength and frequency are inversely related. And if our wavelength is short, our frequency is what? High. And our energy is also
High.
what do we say about amplitude and intensity?
Amplitude is the distance from the middle crest,
Basically the height of that wave.
okay.
So if the amplitude is high, that means our intensity is also high.
Oh, yeah. Is it inverse?
Okay, time to solve this problem. What is the wavelength of electromagnetic radiation with a frequency of 1.5 times 10 to the power of 12 hertz? Okay, so first we need a formula, right? So it's going to be frequency equals C, which represents what? Speed of light divided by wavelength. And we already know what C is, 3 times 10 to the power of 8. And our frequency, we know it because it's in the problem. So all we need to do now is plug that into our formula. So I have it written out. 1.5 times 10 to the power of negative 12 equals C divided by our wavelength. So, how are we going to get that wavelength by itself? We are going to do a cross multiplication, right? So then I'll rewrite that as 1.5 times 10 to the power of negative 12 cross multiplied with our wavelength equals 3 times 10 to the power of 8. Everyone good so far? No.
Yes, sorry.
Okay. So now we have this written out like this.
Yes.
And to get our wavelength by itself, what would we do? Divide both sides by our frequency. So like this. So these two will cancel each other out. And then we are able to solve for the wavelength by dividing these two. Anyone confused?
One question.
Yes.
Can you leave it as a fraction or do you want us to simplify?
Well, I'm pretty sure she's not.
Yes, you have to give it to me in exponential form.
Ma'am, I have a question.
Yes.
How does 3 divided by 1.5 become 2?
No. 3 times 10 to the power of 8, this whole thing divided by this whole thing.
Yeah, but 3 divided by 1.5 cannot be 2.
No, Shaheen, we're not dividing 3 with 1.5. We're dividing 3 times 10 to the power of 8, that whole number, divided by this whole number. So when we write this number out, what does it become?
3 but
Yeah, but ma'am,
Like 3.
like 10 to the power of 8 cancels with 10 to the power of minus 12 and you get 10 to the
Billion?
minus 4. So that is separate, right? And so then you end up, like if you're doing you end up dividing 3 by 1.5.
7.
No, but you're not
Maybe it's 2
separating.
point something, so then you.
No, we're not trying to separate these numbers.
No.
If you would use the calculator, you would enter this whole thing divided by this whole thing.
Oh,
That
so
would just be
so
10 million.
300
You won't get.
300
Does the calculator on the, do you guys know if the calculator on the
Double check.
test program does it?
She said we can have scientific
I would
Would-
think of achieve.
Oh, okay,
So
we
This
bring it
divided
or
by
she goes?
this is actually
Okay, we
3
gotta bring
divided
it.
by 1.5 to the
So
into
he-
10 minus into
Shaheen,
into minus 4. It can't be 3 divided.
Shaheen, you're not dividing 3 by 1.5. So turn that scientific number into the decimal. So
Yeah, but even if you do that, you'll see you're dividing 3. I don't know, let's see what you get.
Shaheen, it goes from
1
30
second, guys,
million
1 second.
30 million divided by 0.000000015. Does that make sense?
1.5 into 2 is 3, right? Yes, ma'am, I'm looking 1.5 into 2 is 3.
I
Yes,
did.
ma'am. It is 2, ma'am.
It is?
Sorry. It is 2, sorry, ma'am.
I did.
I don't know,
Okay.
I don't know what I was thinking.
Okay, so it is right.
3 divided by 1.5 is 2. But 1.5 divided into 2
Huh?
is 3. Sorry, ma'am. Sorry.
I'm so lost.
We'll probably just come back to that.
I don't understand how you were trying to figure it out.
Because you just
Oh,
need
yeah,
to separate
like,
the exhibit
You're
is
trying to separate the numbers.
Yeah.
She was doing it in like a different way.
But this is what we do it because you did, and it's
She
actually.
said that it is too, so.
Oh, okay, you were saying.
Well, I would imagine because 1.5 times 2 is 3.
Yeah, exactly, that is what, and I was, as you know, I was having
Okay.
a block, sorry. ma'am.
Girl, you confused
That's
me.
fine, that's fine.
Okay, okay, let's go.
Miss Winnie, can you show us how to do that on a calculator though?
Yes.
You just type it in.
On your phone.
If you have a scientific
Oh.
calculator,
Oh,
you should be
sorry.
able to.
You literally
Hey,
just
I-
type it in the way it is.
3
Yeah, on a
times 10 to the
scientific
power
yeah,
of
but on the
8
phone you can.
Yeah.
And on the exam soft
divided
calculator you
by.
can't.
No, there.
Miss Bonilla?
Yes.
Where did the negative 12 come from?
Oh,
Oh, it's
I guess
positive
that's a
12.
typo up there. It should say negative 12 up there.
Okay, I was kind of lost on the job. So that would have been 2 times 4 to the 4th, or 10 to the 4th. Not.
No, she said there's a typo up there,
No,
so that
up
should be
there, it
negative
should
12.
be negative 12.
Oh, okay.
Yes.
May I approach?
Yes, you may.
Yeah.
Thank you.
Do you swear to tell the truth and only the whole truth?
I will try.
Yes.
Where is the button at?
Okay, we'll do this when we work on our worksheets. You show me.
Yeah. Thank you.
Okay, so you guys will understand the math when we work on the worksheets, and I'll come around and help you guys.
The little triangle thing, like the calculator did?
All right, moving on. So, last lecture, I told you guys something about wave-particle duality. What does that mean?
Like wave or particle.
Yes, so electromagnetic radiation can either act like a wave or a particle, depending on the energy. So, lower energy radiation acts more like a wave, and then higher energy radiation, such as X-rays or gamma rays, they act more like particles. So, from that, we're going to go into the intensity of the radiation. And what does Coulomb's law say about intensity and distance? You guys remember?
Distance is inversely proportional to the intensity.
No, the intensity is inversely proportional to the square of the
The
distance.
distance.
Mhm. And what is the second part of this inverse square law?
D2 squared equals
D2 squared over, yes. So what that means is the intensity of radiation decreases with the distance. So the further away you are, the intensity decreases. This is like that Sitter-Rosad formula.
I forgot about that.
You said the further you are,
The further you are, the intensity of the radiation goes down. Okay, so we're going to use that formula now. If a light source has an output of 1,000 lumens at 2 meters, what will be the intensity at 4 meters? So, we need to plug some numbers in. Intensity 1 is going to be 1,000. And it's asking for intensity 2. Distance 1 is going to be 2 meters. And then distance 2 is going to be 4 meters. So all we're gonna do is take all these numbers and plug that in. 4 squared is what?
16.
16, okay? And then 2 squared is 4. So we're gonna do some cross multiplication and division, which is gonna give us our answers.
Intensity is measured in units.
Because we're talking about light source. That's why we're using lumens.
Is lumens measured universally, like SI and metric or Imperial? Like, would there be another word for loonies instead of?
I would have to look at it. But
Or
this was
test
just
the-
as an example, this won't be on the test.
Okay.
I won't ask you what's the SI unit for lumens.
Cool.
Alright, so I'm gonna pass out these spreadsheets.
Like right there.